From the shining pipes inside a skyscraper in New York to the heating systems in the freezing winters of Alaska, copper is everywhere, silently carrying water, gas, and life itself. But how do you turn a chunk of raw metal into miles of perfectly smooth, leak-proof copper pipes that can last over 100 years? Today, we'll go inside one of the world's largest copper pipe factories in America, where molten metal, fire, and precision machines work together to create the veins of modern plumbing. Welcome to the supergiant copper pipe factory, where fire becomes function and metal becomes life. The story begins deep underground. Copper ores are mined from vast open pits in states like Arizona, Utah, and New Mexico, places where the earth literally glows with metallic veins. These rocks are crushed, ground, and refined through a complex process called smelting. At over 1200 degrees Celsius, the impurities burn away, leaving behind 99.9% pure copper cathodes, flat, reddish plates that shine like solid sunlight. These cathodes are the foundation of everything made in the factory. Each plate weighs around 80 kilograms, and the factory consumes hundreds of tons per day. Before heading into the furnace, they are cleaned and loaded into massive crucibles, ready to begin their transformation from solid to liquid, from raw to refined. Inside the induction furnace, copper cathodes are melted down to a glowing liquid metal. The temperature, 1085 degrees, hot enough to melt steel's soul. Every second, thousands of kilograms of copper flow through channels into continuous casting molds. Here, it cools just enough to solidify into thick cylindrical billets, about 6 inches in diameter and several meters long. Each billet is then carefully cooled, straightened, and cut, forming the raw blocks that will later become long, flexible pipes. Operators check every billet for surface flaws, bubbles, or cracks, because even the tiniest defect could cause a leak years later. These copper billets now shine like red-orange pillars of molten energy, ready for the next stage, shaping. This is where the real magic happens. The billets are reheated to around 900 degrees Celsius, soft enough to flow like clay under pressure. Then, using a hydraulic extrusion press, each billet is pushed with over 3,000 tons of force through a die, a specially shaped steel mold that creates a hollow core inside the solid billet. What emerges from the other end looks almost impossible. A perfectly continuous copper tube, glowing bright orange, sliding forward like molten silk. Workers watch closely as lasers measure the diameter, wall thickness, and uniformity of every inch. If something's even a fraction of a millimeter off, the tube is automatically rejected. The copper cools quickly as it moves along conveyor belts, slowly turning from fiery orange to metallic red. This extrusion line can produce hundreds of feet per minute, creating miles of copper tubing every hour. But the copper pipes aren't done yet. To achieve the exact size and mechanical strength needed for plumbing, they must go through a process called cold drawing. The tubes are first cleaned and coated with lubricant. Then they are pulled through smaller dies, one after another, reducing their diameter while increasing their length. Each pass makes the copper denser, stronger, and smoother inside, perfect for carrying water and gas under high pressure. This process can stretch a single billet into over 100 meters of finished pipe, a remarkable transformation from a solid block of metal to a flexible, reliable conduit. Copper is strong, but after so much stretching, it becomes too hard to bend. That's why the next step is annealing, a controlled heating process that softens the metal without melting it. The pipes pass through long furnaces, each section heated with precision sensors and temperature zones. At around 400 degrees Celsius, the crystal structure of copper relaxes, restoring its ductility and brilliance. When they emerge, they're quickly cooled with water mist and air jets. locking in both strength and flexibility. Now these pipes can be coiled, bent, or shaped without cracking, ready for real-world plumbing installations. At the final production stage, precision machines cut each pipe to the required lengths, from small 10-foot tubes to massive industrial coils. Once approved, the pipes are bundled, capped, and wrapped in protective plastic, ready to travel across the country. From these factories, the copper pipes go to construction sites, hospitals, HVAC systems, and even ships, anywhere water and energy need to flow reliably. Here's something truly amazing about copper. It's 100% recyclable, forever. In fact, nearly half of all copper used today in the US comes from recycled scrap. In the factory, every shaving, every offcut, and every rejected billet is collected and remelted, going right back into the production line. Even copper pipes removed from old buildings are returned, melted, and reborn into new pipes. This closed-loop system saves enormous energy, reduces mining waste, and makes copper one of the most sustainable metals on Earth. In a time when eco-efficiency matters more than ever, copper remains a shining example of how industry and nature can work hand in hand. Though the process is highly automated, the human element is everywhere. Engineers monitor sensors, read temperatures, and fine-tune extrusion pressures. Technicians inspect the surface of every pipe. And in control rooms, operators oversee miles of conveyor belts through glowing windows, where molten metal becomes the future. Each worker is part of a system that runs 24 hours a day, 7 days a week, producing millions of feet of copper pipes every month. The scale is staggering, but so is the precision. Every inch of pipe that leaves the factory is the result of both industrial power and human craftsmanship. If you love learning how the world's biggest factories transform raw materials into everyday life, don't forget to subscribe to our channel. Copper, the reddish-golden metal that powers our homes, our phones, our computers, and even our cars. Every year, the world consumes over 25 million metric tons of copper. But did you know that nearly 1/3 of it doesn't come from mines? Instead, it comes from recycling. In today's episode, we'll step inside a supergiant copper recycling facility where millions of old wires are stripped, shredded, melted, and reborn as brand new copper. Ready to fuel the modern world again. This is recycling on an unimaginable scale. Before we dive into today's mind-blowing journey inside a supergiant copper recycling plant, make sure you hit that subscribe button and turn on the notification bell. On this channel, we explore the hidden world of mega factories, incredible processes, and the amazing ways everyday things are made. Trust me, you don't want to miss what's coming next. Copper is one of the most valuable metals on Earth, not just for its conductivity, but also because it can be recycled infinitely without losing quality. That's right, copper can be melted down and reused again and again, always as good as new. Mining fresh copper ore is expensive, destructive to the environment, and energy intensive. But recycling copper? It saves up to 85% of the energy compared to mining. That's why copper wires, pipes, motors, and even tiny scraps are collected worldwide to be reborn. And where does a lot of this copper come from? Discarded electrical wires. Inside this plant, mountains of tangled multicolored wires, once used in homes, electronics, and vehicles, wait for their second life. It all begins with trucks rolling in. carrying tons of used copper wires. These might come from construction demolitions, old appliances, or even massive utility upgrades. At the facility, workers and machines sort the incoming wires. Thick, high-purity copper cables are separated from mixed wires that contain more insulation and impurities. Everything is weighed and tracked. Even at this early stage, nothing goes to waste. Every kilogram of copper has value. Next, the wires move into industrial wire stripping machines. Imagine giant rollers with sharp blades peeling off the rubber or plastic insulation at high speed. Some wires are stripped clean. Others are shredded into tiny fragments. The shredded mix is then fed into a granulator, a powerful machine that tears the wires into small pieces, separating copper from insulation. On one side, you get shiny copper granules. On the other, heaps of plastic waste. But here's the mind-blowing part. With advanced separation systems using airflow and vibration tables, this plant achieves up to 99.9% purity copper recovery from shredded wires. The clean copper granules are then transported to the melting furnace. Here, temperatures soar above 1085 degrees Celsius, 1980 degrees, the melting point of copper. Giant crucibles swallow thousands of kilograms of copper, glowing molten red as impurities float to the surface. Skilled workers remove the slag, leaving pure liquid copper. This stage is mesmerizing, a river of glowing metal, ready to be reborn. The molten copper is then cast into giant shapes, depending on its next use. Sometimes it's formed into copper rods, which later become new wires. Other times, it's cast into cathodes or billets, used for industrial products like motors, electronics, and even coins. Each cast piece is cooled, cut, and inspected for quality. The copper that was once a tangle of waste wires is now indistinguishable from brand new copper mined from the earth. But what about all that insulation stripped from the wires? Surprisingly, it's not wasted. The plastic is shredded further and sometimes used as fuel in cement kilns, or recycled into other products like mats or piping. In this circular process, almost nothing is thrown away. This one facility alone can recycle hundreds of thousands of tons of copper wire every year. Globally, copper recycling saves over 100 million megawatt-hours of energy annually, enough to power entire nations. Without recycling, copper would quickly become scarce, and the cost of electronics, cars, and renewable energy infrastructure would skyrocket. As the world electrifies, building more solar panels, electric vehicles, and wind turbines, the demand for copper is expected to double by 2050. Mining alone won't be enough. The real secret weapon is recycling on a massive scale. From an old phone charger to a skyscraper's electrical wiring, every piece of discarded copper has a future. And giant recycling plants like this one ensure the cycle never stops. If you enjoyed discovering how millions of wires are reborn, don't forget to like this video, subscribe to our channel, and hit the bell icon so you won't miss the next incredible journey into the world of mega factories and mind-blowing processes. Titanium, a word that instantly sparks images of strength, lightness, and futuristic engineering. This silvery gray metal is stronger than steel, but nearly 45% lighter, resistant to corrosion, and capable of withstanding extremes of temperature and pressure. From jet engines to spacecraft, from surgical implants to smartphones, titanium has become one of the most sought-after metals on Earth. But have you ever wondered, how do we actually mine this super metal? In this episode, we'll take you on a journey deep into the world of titanium, how it's mined, processed, and transformed into the backbone of modern technology. From open-pit mines to high-tech chemical processing, from raw ore to shiny titanium ingots, you're about to witness one of the most mind-blowing processes on Earth. But before we dive in, make sure to hit that subscribe button and ring the bell, so you never miss our deep dives into the industries that shape our modern lives. Now, let's uncover the secrets of titanium mining. Titanium isn't found in its pure form in nature. Instead, it hides within mineral ores, primarily ilmenite and rutile. These minerals may not look like much, just dull black sands or reddish-brown rocks, but inside them lies one of the most valuable materials for modern technology. Discovered in the late 18th century, titanium was initially impossible to isolate in pure form. It wasn't until the 20th century that new chemical processes made it possible to produce titanium metal commercially. Since then, global demand has skyrocketed, with applications in aerospace, defense, medicine, and consumer products. The largest deposits of ilmenite and rutile are found in countries like Australia, South Africa, Canada, India, and Mozambique. Some are mined from beach sands, where centuries of erosion have concentrated heavy minerals. Others are extracted from open-pit mines, where excavators and trucks move millions of tons of earth each year. The scale is staggering. A single titanium mining operation can process tens of millions of tons of ore annually, yielding hundreds of thousands of tons of titanium feedstock. These numbers are what make titanium mining supergiant. And yet, even after extraction, titanium's journey is just beginning. Unlike iron or copper, titanium cannot be smelted easily. Its strong affinity for oxygen makes it stubborn. It resists simple refining. This is where human ingenuity comes in. Titanium mining typically begins with surface mining. Bulldozers strip away vegetation while excavators dig into mineral-rich sands or ore deposits. Giant dump trucks, each carrying up to 400 tons of material per load, haul the ore to processing plants. In coastal regions, dredge mining is often used. Enormous floating dredges suck up sand from riverbeds or lagoons, separating heavy minerals like ilmenite from lighter quartz grains. Conveyor systems then move the concentrated material for further processing. At the processing plant, the raw ore undergoes gravity separation and magnetic separation. Since ilmenite and rutile are heavy and often magnetic, they can be separated from ordinary sand using specialized equipment. After multiple stages, what remains is a concentrated mineral feedstock, rich in titanium dioxide. But here's the challenge. This isn't metallic titanium yet. This feedstock must go through intense chemical refining before it can become the shiny, strong metal we recognize. The next stage is perhaps the most fascinating, turning titanium ore into titanium sponge, a porous metallic form of titanium that can later be melted and shaped. The most widely used method is the Kroll process. Producing titanium sponge is labor-intensive and expensive,